Today we will discuss chapter 7 sound. First of all, what is sound? Sound is basically a kind of energy. In definition term, we said it sound is a kind of sensation received by the ears and carried to the brains, which is responsible for hearing. Okay, and the material bodies which are capable of producing sounds are called sources of sound or sounding bodies. For example, different kinds of musical instruments. Okay, now sound basically two types. One is called pleasant sound and one is called unpleasant sound. Pleasant sound means which sounds are nice, sweet, and unpleasant means loud, basically noise, which creates noise. Okay, so nice which sounds, any musical sounds, loud or noise, any loud volumes of music box, TV, that's a burning of patakas in pujas, that kinds of thing. Okay, these all are categorized under sound. When we hear any sound, when there is a vibration, when there is a vibration passes through the materials, through a medium, the medium can be solid, liquid or gas, then we hear the sound. The vibration passes through that medium and create a sound. So basically sound travel to a material medium with a definite speed in a form of a wave. The vibration is known as wave. Okay, now the wave can be two types. Okay, okay, then the two, one is called transverse wave and another one is called longitudinal wave. Okay, now in case of transverse wave, the motions of the particles of the medium are perpendicular to the direction of the wave propagation. Okay, and it is like this. Okay, and in case of longitudinal wave, the motion of the particles of the medium are parallel to the direction of wave propagation. Okay, it is perpendicular and it is parallel. In case of longitudinal wave, it is look like, okay, like this. Now in longitudinal wave there are two terms. Okay, one is compression and one is rarefaction. Okay, compression means when the part of the medium, when the density of the medium is maximum, that is, it is like this. Okay, and the rarefaction means when the part of a medium density is minimum and it is look like this. This is compressibility and this is rarefaction. Longitudinal wave is a combination of compressibility and rarefaction. Now there is a term called progressive wave. What is progressive wave? A disturbance that moves through a medium, transferring energy from one point to another without any physical transport of the material between the points is called a progressive wave. Okay, there are some properties of progressive wave. That are, progressive waves are produced due to periodic motion of the particles of the medium. Each particle of the medium executes exactly similar vibration about their mean positions. Depending on the directions of these vibrations with respect to that of wave motion, the wave may be transverse or longitudinal. Third one is depending on the density and elasticity of the medium, the wave moves in the medium with a particular velocity. Fourth one is wave transports energy through the mediums but not the medium itself. Fifth one, when a wave passes through a medium, every particles of the medium passes through same changes in pressure and density. So these are the characteristics we must know about any progressive waves. Now there are some terms related to waves. That's a amplitude. Okay, first one. Second one is frequency. Third one is period. Fourth one is wavelength, and fifth one is wave velocity. Okay, and we have to define each and every term. Okay, let's think of a sound wave. It moves like this way. Okay, now this line shows the time. Okay, now first thing is amplitude. What is amplitude? Amplitude means the maximum displacement of the particle from its mean position when a wave passes through a medium. Okay, that means the maximum distance it covers when it passes through a medium. Here the maximum distance is this. This is the maximum height. So the amplitude will be this one. This is the maximum height. It is reach. The sound wave reach this maximum height. So the amplitude will be this. This is known as amplitude. Okay. The next one is frequency. Frequency means the number of complete vibration made per unit of time by a particle in the path of the wave is called the frequency. Okay, the frequency means per unit time, in per unit time, the number of complete vibration. Okay, for example, in this unit time it completes this one. Okay, in this one oscillation. So frequency basically is the number of oscillations per second. Okay, this is one oscillations. So per second, in per second how many oscillations are there, that is known as the frequency, and the unit of frequency is hertz. Okay, now third one is period. What is period? The time required to complete one oscillation, that is known as the period or time period. To complete one oscillation, the time required is known as time period. Okay, so it is denoted by capital T. Okay, so capital T equal to 1 by n. Now n means the number of frequency. N defines number of frequency and T means time period. Then there is wavelength. Okay, wavelength means the shortest distance between any two particles in the path of wave. That means any two wave. This is a wave, this is a wave. The distance, shortest distance. This is defined as wavelength. This is wavelength. Shortest distance between any two particles in the path of the wave, and it is denoted by lambda. This is called lambda. Okay, lambda. Now what is wave velocity? Wave velocity is basically the product of frequency and wavelength. Okay, it is known as the wave velocity. We define this by capital V. So capital V equal to n lambda, product of frequency and wavelength. So it is a formula. Using this we solve many maths in this chapter. Now there is law of reflection of sound. What is the law of reflection of sound? Law of reflection of sound states that the angle of reflection is equal to the angle of incident. This is the angle of incident wave, and this is the angle of incident wave I, and this is the angle R is of reflection. So according to the first law, angle I equal to angle R, and the second law said the reflected sound ray, the incident ray and the normal at the point of incident on the reflecting surface lies on the plane ray. The incident wave, the normal and the reflected wave should lies on a same point, that is this on the reflected ray. So these two are the law of reflection of sound. Okay. Now using this law of reflection of sound, there are some real life application, that is a speaking tube, gramophone horns, stethoscopes, where this law of reflection of sound are used. For example, speaking tube. What is speaking tube? Speaking tube is which is used for the speaking purpose between two persons, where the one person would be the one side of the speaking tube and another will stand in the other side. That means speaking from, or you can see it like that, speaking from one room to another, or from a large building, means there is a long distance between there. Okay, so it is so that kind of thing is a speaking tube. So in that kind of things, we use the law of reflection of sound for reaching the sound. Okay. Now there is a term called echo. This is come with whenever we talked about sound. Echo means whenever we say something in a open space, sometimes we see that after saying it, the words come in a repetition from other side. When in the hills we say something, so from the hills we get the repetition of the same sentence or words we said for sometimes. This is known as echo. When a sound after reflection from some reflector is again heard separated from the original sound, then the reflected sound is known as echo. Okay. Now why it is happened? Okay. Now to having a echo, there should be a minimum distance between the listener and the reflective surface, and that should be 17 meter. The minimum distance between the listener and the reflecting surface should be 17 meter to having the reflection of the sound, to having the echo. And how we find it? Now we know time equal to total distance traveled by the speed of the sound. The speed of the sound is defined by v, and total distance travels, the sound will go again come back, that means 2 into d. So d equal to vt by 2. Now the speed of sound is 340 meter per second, and the t will be the reflected sound. For the reflected sound must stay for 0.1 second. Okay, this is the thing. So after solve it, we get 17 meter. Okay, so that's why the minimum distance between the listener and reflected surface should be 17 meter for having a echo. Now there is a thing named sonar. What is sonar? Sonar means sound navigation and ranging. Okay, sound navigation and ranging. In sonar, we used to receive we use this thing to receive sounds in case of very long distance or very depth distance. For example, we use it for ultrasonography, ultrasonic sounds. In case of ultrasonic sounds, we use sonars to catch the sounds. Okay, in case of submarine or to find anything inside the depth of the sea, we use this kind of things. Now what is ultrasonic sound and what is audible sound? Okay, now ultrasonic sound, we all know that audible range of sound belongs to 20 hertz to 20,000 hertz. If the frequency range of a sound is between 20 hertz to 20,000 hertz, then it's an audible sound. We heard these sounds. But when the range is more than 20,000 hertz, then it's known as ultrasonic sound. And when it is below 20 hertz, then it is known as infrasonic sound. Okay. So in case there are some animals who can detect the infrasonic sound, and that's why they are found behave very oddly before the earthquake, because if until the sound is within 20 hertz to 20,000 hertz, we cannot understand. But some animals are there who understand the vibration below 20 hertz. That's why they, before human, they can understand that there is an earthquake. That wise they behave improperly. Okay. And ultrasonic sounds, the sounds above 20,000 hertz. There are many uses of ultrasonic sounds. That is, in case of water communication, we use ultrasonic sounds in to find the depths of a sea, what is there in the depth of a sea. In case of medical term, we use ultrasonic sound waves for ultrasonography. Then in liquids like milks, to kill the bacteria, we use ultrasonic waves. Like there is in case of echocardiography, we use ultrasonic waves. So there are some things that we use in case of ultrasonography waves. In this ways we use ultrasonography sounds. Okay. Now there are three terms related to sounds are, three things related to sounds are loudness, pitch and quality. These three things define whether a sound is a pleasant sound or it is an unpleasant sound. Okay. Loudness means, loudness is the property by which a loud sound can be distinguished from a faint one, both having same pitch. Okay. So if the sound is very loud, then it is known as unpleasant, and it is a sweet sound, then it is a soft sound, then it is known as pleasant sound. Then is pitch. Pitch is basically a characteristic of sound by which a shrill note can be distinguished from a dull or flat note. So this is known as the pitch. So basically pitch is basically used in case of musical sounds. Okay. In case of musical notes, they have a pitch, a low pitch, a high pitch, that's all. And then third one is quality. Quality basically is it differentiates two sounds from each another. Okay. Maybe there are some sounds which have same loudness, same pitch, but they must have different kind of quality. The quality of each and every sounds are different from each other. Okay.